In this unit, we're going to be covering a series of formulas called the gas laws that show the relationship between pressure, volume, temperature, and the amount of gas in a sample. We're going to start with some basic definitions, what is pressure and how we measure it, and then we're going to move into the first two gas laws, Dalton's Law and Boyle's Law. Pressure is a certain amount of force applied over a specific amount of area. So in the case of gas particles, these molecules and atoms are moving around and they're constantly bumping into their container, whether that's a gas cylinder or the walls of a room or a balloon. They bump into the sides of those containers, and that little tiny amount of force that is caused by the particle bumping into the wall is applied over a very, very tiny area. So it's a little tiny amount of pressure, but then that gets multiplied trillions and trillions and trillions of times for all of those gas particles, and it adds up to the pressure that we can see that fills a container or inflates a balloon. There are a couple of different devices that we use to measure pressure, and the ones that we use in current times look a lot different from the originals, but the barometer, which is the one that they would refer to, for example, on a weather report, is used for measuring atmospheric pressure, the pressure in the air around us. And the original barometer was a tub of mercury, and it had a tube with one end closed that was inserted into it, sort of like a straw, except closed on the top. And what would happen is the pressure pushing down on the surface of the pool would then force mercury up into the tube, and as the atmospheric pressure changed, the level of the mercury inside the tube would go up and down, and that's how you measure changes in atmospheric pressure. 760 millimeters of mercury, so when the mercury rose to a height of 760 millimeters, that was considered normal pressure, and then it would go up and down from there. Another device is called a manometer, and a manometer is used not for measuring the outside pressure, but measuring the pressure inside of a sealed container. So what happens is you have this tube, again, filled with mercury in this case, and you have a chamber filled with gas. When you release that gas into the tube, it presses down on one side of the mercury, which causes the other side of the mercury to rise, and you measure the relative pressure by finding the difference in the levels, because they start out equal, and then they change as the gas presses up on one side, or down on one side, which forces the other side up. There are a number of different units that you would see representing pressure, and it would be atmospheres, which is abbreviated ATM. That's the most common one you would see in this class. The old sort of original, which we saw in the barometer example, was millimeters of mercury, or mmHg. Torr is a unit that's equal to millimeters of mercury, but named after Torricelli, who invented the barometer. And the international unit is pascals, PA, or you will sometimes see kilopascals, kPa. So these values, 1 atmosphere is equal to 760 millimeters of mercury, or 760 torr, and then 101.3 pascals. All of these represent the same pressure. So if you ever needed to convert, these would be the values that you'd use. Also, again, when you're looking at word problems, one of the key factors in solving these gas laws problems is knowing what you're working with. If you see any of these values, atmospheres, millimeters, mercury, torr, or pascals, you're working with pressure. So that's important to identify. The first in this series of equations called the gas laws is Dalton's Law of partial pressures. And Dalton's Law says that when you mix gases together into a single container, then the total pressure of the mixture is equal to the sum of all the partial pressures of the gases that you mixed. So if you start out with two gases and they're each at 1 atmosphere of pressure, and then you combine them into the same container, the new pressure would be 2 atmospheres. You just add them together. And it's important to note that the pressure contributed by each gas is affected by how much gas there is, the number of moles, how much volume there is, the size of the container, and what the temperature is. It is not affected by what the gas actually is, whether it's hydrogen or CO2 or water vapor or oxygen. They all behave the same way in this case. So you don't need to worry about what type of gas it is, but you need to worry about how much there is, how big is the volume, and what is the temperature, and that will help you find the pressure. So the formula for Dalton's Law is that the total pressure is equal to the pressure of gas number 1 plus the pressure of gas number 2 plus the pressure of gas number 3, etc., up to however many gases you have. So in this case, in the example here, if we mixed helium and nitrogen gas, and let's say we know that the helium has a pressure of 1.5 atmospheres, and when we mix them together, we measure the pressure at 4 atmospheres. Well, what's the pressure of the nitrogen before you mix it? Well, it's the difference, because the two partial pressures of helium and nitrogen have to add up to the total. So 1.5 plus 2.5 would give you 4 atmospheres. So we can find the missing gas by subtracting the known amounts from the total. Or if you have all of the partial pressures, you can add them together to find the total. So here's an example, similar to the one I just showed you. We have a mixture of 3 gases, oxygen, carbon dioxide, and nitrogen. And we're told that the total pressure is 0.97. So total is 0.97. The carbon dioxide has a pressure of 0.7 atmospheres. The nitrogen has a pressure of 0.12 atmospheres. And we don't know what the pressure of the oxygen was. Well, we can figure that out because if you add these two numbers together and then subtract them from the total, what's left is 0.15 atmospheres. That equals the pressure of the oxygen gas, because all 3 gases have to add up exactly to the total. And so this is just showing you that again. We know that the 3 gases have to add up to the total. So if we rearrange that equation, we subtract these 2 gases, right, the total minus the CO2 minus the nitrogen, and then we plug in the numbers we have, the total, the CO2, and the nitrogen, we get the partial pressure of the oxygen. What is the total pressure of a mixture of 3 gases? Okay, hydrogen is 600 millimeters, and the helium is 439. Or sorry, the total is 600. And we know that the helium is 439, so the total is 600, helium is 439, and the question is, what's the hydrogen? Well, we would do 600 minus 439, and we'd find that the hydrogen gas is equal to 161 millimeters of mercury. What is the total pressure of a mixture of gases if we have a partial pressure of 5 kPa plus 4.56 kPa plus 3.02 kPa and 1.2 kPa? Well, in this case, you're just adding them all together, and you'd get 13.78. You just total all of the pressures up, and that gives you the answer if you're just trying to find the total. Okay, this is another problem where we have the total. We're given the total of 30.4. We're also given the partial pressures of 2 other gases, which is 16.5 and 3.7. And we need to know what is the partial pressure of CO2. Well, we would do 30.4 minus the 16.5 plus the 3.7, and we would find that the CO2 has to have a pressure of 10.2.